Welcome to the Fifth Stages Mini Partner Workshop in our second year of our program. Today, we are joined by two partners, the Mission-Aransas National Estuarine Research Reserve and the National Wildlife Federation. Before we get started with the presentations, I'd like to go around the room, for those joining us online also, and give some introductions. So if you can provide your name, your title, or for the students, what your degree program is, and then your area of focus or research interests. I'll start. My name is Audrey Douglas. I am the program coordinator for the NSF-funded research traineeship on stakeholder-guided environmental science. So you've all received a lot of emails from me. My background is in coastal and marine system science with an emphasis on groundwater surface water interactions and the influence of submarine groundwater discharge on nutrient budgets. Quincy, you can get us started.
My name is Quincy, and I'm a master's student in the CMSS program, and my background is in meteorology, and I study extreme precipitation as well as tornadoes and cyclones.
My name is Justin. I am a coastal marine system sciences PhD student, and I study organic matter cycling in marine systems.
Hi, my name is Allison. I'm a PhD student in the Coastal and Marine System Sciences program. I'm working on analytical chemistry, method development, and nitrogen biogeochemical cycling.
Hi, my name is Mandy. Hi, my name is Mandy. I'm a master's student for chemistry, and right now I'm studying seagrass genetic diversity as it relates to alkalinity and groundwater output.
Hi.
Yes.
Hello. Hi, my name is Mahima. I am a first year master's student in the marine biology department advised by Dr. Yajwan Lin, and my research focuses on the microbial ecology within the Gulf of Mexico.
Hello, my name is Remy Abe. I am a chemistry master's student, part of the chemistry program. My research is focusing on toxicology and its interaction towards epigenetics.
Hi, my name is Ifeanyi. I'm a first year PhD student in coastal and marine systems program. My research is focused on assessing the impacts of flood events on groundwater pollution. Thank you.
Hi, my name is Laura. I'm a master's student in the Coastal Marine System Science program, and my research focuses on groundwater pollution and social science.
It's good idea to stand up, Dr. Douglas. My name is Philip Tissot. I'm at the Conrad Butcher Institute, the chair for coastal artificial intelligence. My work is at the intersection of AI and coastal processes, and I'm one of the NRT faculty members that you'll hear about.
Hi, I'm Jenny Pollock. I am a professor in the life sciences department and the chair for coastal conservation and restoration at the Hart Research Institute. And I'm also one of the NRT faculty.
Oh, yeah, I didn't notice there are people on the screen. So my name is Shinping Hu. I'm a professor of chemistry. So I meant to alert Audrey, we have another pair of stakeholders sitting in the back. So just look at the screen only. So I'm also at the Hart Research Institute, chair for ecosystem science modeling. My specialty on the chemical oceanography, ocean acidification.
Hi, my name is Yajwan Ling. I'm an assistant professor in life sciences. I'm a biological oceanographer. We do lots of field works. I study the biological carbon pump in the ocean and its relationship with microbiome and the phytoplankton. Thank you.
My name is Katie Swanson. I'm the stewardship coordinator and acting manager for the Mission-Aransas NERR.
Hi, and I'm Victoria Congdon. I am the research coordinator over at the Mission-Aransas NERR as well, and I'm primarily interested in seagrass ecology and how really disturbances affect these communities.
Online, let's start with Patrick.
Yes, Patrick Nye, Ingleside on the Bay, Coastal Watch Association. And while I'm on the line, Lucy, I sent you some information last week, I believe, or maybe 2 weeks ago. I'm making sure that you received it. Thank you.
Lucy?
Hi, I'm Lucy Flores. I'm with the Texas General Land Office. I'm a project manager under the Water Resource Team. You guys saw Jason the last presentation. I'm a project manager for Texas Beach Watch and the Texas Coastal Ocean Observation Network for the GLO. Patrick, I did get that information. Thank you so much.
Okay, and Arso?
Hi everyone, I'm Arsam Pathak. I am the Senior Adaptation and Coastal Resilience Specialist for National Wildlife Federation.
Okay, thank you everybody for your introductions. So again, we do have two partners with us today. Arsom actually has to leave around 1:30, so she's gonna get us started. So I hand it over to you.
Thank you. I'm gonna go ahead and share my screen. Just very quickly for my background, I have a background in coastal climate sciences. I received my PhD from University of South Florida in Tampa, working on sea level rise and storm surge changes, but also looking at the policy context of adaptation decision making in small islands. So I have been really fortunate with this position where I get to apply a lot of my research skills to the policy and advocacy work that we do at the National Wildlife Federation. And for anyone, well, let me make sure you all see my screen. Just quick thumbs up. Okay, perfect. So for big picture framing and context, National Wildlife Federation, we are one of the largest science-based conservation organization. The way my science and a lot of other research folks fit within the organization is providing that research and scientific support to the policy and advocacy work that we do in terms of wildlife habitat management, biodiversity conservation, the broader ecosystem conservation and restoration. I work for the South Central region, which has these different programs, one of which is the Texas Coast and Water Program. Through this program, I work with a wonderful team, which includes our senior director, Jennifer Walker, who leads the program. And then we have the comms manager taking care of our media pitches, a lot of our big picture outreach and advocacy. And then we're hiring for a new policy director. So a lot of folks are in the hiring process and cannot make up for this call today, but I try my best to give you all a good sense of what our program is, what we do, the work that we do through this umbrella of Texas Living Waters Project, and then some of the gaps and research questions that you all can help us dig deeper into. So with National Wildlife Federation, we have these 3 buckets of focuses, which includes the wildlife recovery and habitat restoration. There's also a big focus on environmental justice and thriving communities, and then advancing climate solutions for building that overall resilience of communities, as well as the wildlife and the habitats. There are different projects that are under these 3 buckets. So for instance, under wildlife recovery and habitat restoration, we do a lot on the environmental flows advocacy. Along the Texas coast, there was this giant flows campaign that we've been participating in. We're also working at the policy and legislature level to strengthen the guidelines around environmental flows. Same with species protection, and then doing legal advocacy around water rights and permits. Under that, environmental justice and thriving communities, we work on holistic science-based solutions like One Water, which is this integrated approach to manage water infrastructure and water systems. So pushing cities like Houston and Dallas and Austin to incorporate these resilience strategies. We work on flood infrastructure and resiliency advocacy, work with the stakeholders on the state flood planning process, and then which is actually the first state flood plan of Texas, and making sure that climate resilience and a focus on equity and the most vulnerable communities is maintained as these plans are shaping. And then also working on the Infrastructure Investment and Jobs Act implementation, which is this big federal pot of money coming towards all the different states and directing these investments and funding towards ecosystem restoration and good projects to happen that benefit both the communities as well as the wildlife. The last one is that climate solutions pillar. This is where a lot of my work falls under. So this includes ensuring that the water supplies and systems are resilient in the face of future climate uncertainties, embedding climate science and planning in different decision-making processes, both at the state and local level. One way we do it is making sure we're part of stakeholder groups for different planning processes like the State Coastal Resiliency Master Plan or the hazard mitigation process. Understanding that these plans that are shaping, they provide a vehicle for a lot of projects to happen at the state level. So it's important that science-based projects are included in these plans that are forming, and that National Wildlife Federation is a key player in promoting these projects in these plans. Then the next one is the vulnerability assessments for the Texas coast. So this has been one of my baby projects and something I've been working during my 3 years at the Federation. But essentially the idea is to provide local understanding of climate risks to communities who most need this information. So under-resourced, underserved communities who do not have access to this data or information, sharing the information on their present and future risks on nature and future risks, and then using that risk-based framing or emphasizing the need for adaptation and the need to build resilient systems. One way we talk a lot about climate solutions at National Wildlife Federation is through nature-based solutions. These are the solutions which are essentially, the idea is to conserve and restore natural systems like wetlands and oyster reefs, and harness the protective services that these systems provide to build resilience along the Texas coast. The overall framing of nature-based solutions, it fits really well within these 3 pillars that National Wildlife Federation works on. So building that climate resilience as an adaptation solution, ensuring that we are focusing these solutions on environmental justice communities and communities that most often need these solutions, and that these solutions, we're not just championing them for their protective services, but also they provide habitat for biodiversity and wildlife that thrives and lives in these systems. As part of Texas Coast and Water program, we also lead this coalition of other nonprofits and conservation groups in Texas called the Texas Living Waters Project. The coalition, in addition to National Wildlife Federation, includes Nature Conservancy, Sierra Club, Hill Country Alliance, and then the Galveston Bay Foundation. Just last year, we went through our strategic planning process as part of the Texas Living Waters Project. And the 6 key goals that we focus on are elevating efficient water management practices all across the state, promoting resilient and equitable infrastructure investment, advancing one water practices. There's this oddly placed body here. But also supporting healthy river ecosystems, launching the Texas Living Waters Policy and Advocacy Hub that a lot of these organizations have been working on, and then strengthening the overall coalition and grow the partnership to include more place-based local conservation groups. And these are the shared priorities that all of these 5 organizations devise together and will be working on for the next 5 years. Just to put in context, I talked about how we use science in the work that we do, but essentially the idea is to take the science and the data that we have, which can then support the advocacy that we do both at the state and local level, and then use that as a tool to push for policy changes. These are some examples of that scientific assessments and reports that we've created. All of these are on the website for National Wildlife Federation as well as Texas Living Waters Project. So I won't go too much into detail. The first 2 are authored by me. So we've done the vulnerability assessment for the Texas Mid-Coast, and then more recently, we've done a similar assessment for Galveston. Again, for both these assessments, the idea is to provide that local understanding of climate risks by compiling the data sets that already exist, and then using that risk-based framing to elevate the need for more adaptation to happen along the Texas coast. And the way we talk about adaptation is through implementing and pushing the needle on natural infrastructure projects. We don't necessarily implement the projects, but the idea is for the decision makers and elected officials in the county to start these conversations on coastal resilience, because a gap we were finding was that these are the counties where people are not talking about coastal resilience or climate adaptation. So playing the role of influencing some of these conversations, convening these different groups and interested stakeholders who have the voice and agency on projects to happen, and then identifying good projects as a way of these assessments, using them as a tool. Also work on the water policy. Again, this is part of that broader Texas Living Waters Coalition. But the idea of it is advocating for projects, for equitable projects at the Texas Water Development Board. Something we've been working on is this Texas Water Fund, and really convincing the residents, communities, and decision makers on the need and efficacy of these solutions. Also working on influencing the equitable funding mechanism. So the state revolving fund and how that can go into ecosystem restoration, natural infrastructure-based flood mitigation, flood control projects. Going back to that climate resilience bucket, just for that high-level framing, I talked about a lot of these things, but the three main things that we've been engaged in is sharing that local understanding of climate risks and solutions to the communities where we're working in, supporting the communities and decision makers in planning and implementing those solutions for adaptation, and then advocating for policy changes at the state level. So again, the idea is to advance these projects and do it at multiple levels by educating the communities, influencing the decision makers, as well as the policy changes where we can. Some specific projects I mentioned about the vulnerability assessments, the idea of which is to build that local capacity and climate resilience. And we did the assessment in the Mid-Coast and Galveston, but we've made a lot of advancement in one of the counties, which is Refugio County. And I shared that project in a little bit. But a few other things that I mentioned earlier is supporting equitable natural infrastructure projects and planning processes. So the Coastal Master Plan and the Hazard Mitigation Plan. National Wildlife Federation was one of the only nonprofits to be on the stakeholder committee for the hazard mitigation project and provided very specific wording for including equity and including natural infrastructure approaches as part of the hazard mitigation planning. And then the last one's doing that broader science-based advocacy. Some things that we are always watching is the Coastal Spine Project, raising questions on the effectiveness of the project, but also just making sure that we are keeping a watchful eye on how that billion-dollar project is forming and influencing the Texas coast. And then a few other things is the offshore wind energy and desalination projects. And as they are happening and taking place, making sure that these projects do not have any unintended consequences for the communities and the wildlife. Just digging a little deeper in that work in Refugio County. So based on what we have, based on the assessment that we did for the Texas Mid-Coast, we were able to have really strong relationship with the county judge. And then a project that we received funding for was a planning grant from the National Academies of Sciences to co-develop a natural infrastructure project with the county. The idea of this was to support coastal resilience in the county through engaging community experts through multiple approaches to identify that project. I know we have Katie in the room. She was part of the advisory board that we formed as part of this project. And then also just facilitating those conversations on nature-based solutions that are available for the county to then identify a solution that is preferred by the community and has the potential to move forward for funding. Blue sky thinking was to create this organized community which can then be able to support the resilience, the overall resilience efforts in the county. We did that through two workshops. The first one focused on presenting the vulnerabilities that the county is facing, and then connecting those vulnerabilities to specific on the ground socioeconomic and environmental concerns. Also sharing information on an understanding of what nature-based solutions are, different types, the case studies all along Texas for those solutions, and what funding opportunities are emerging. And then this was followed by an identification of different types of nature-based projects by the advisory team. You could see this, we came up with 11 really good projects that the community, in the form of this advisory team, identified. And then based on this, they went through a dot polling activity to then prioritize projects based on different parameters and the efficacy and the funding that's available to move these projects forward. We had another workshop where we kept engaging the advisory board. We found that the project that was most prioritized in the first workshop, which was this Living Shoreline project at Black's Point, was still the preferred option. We also did, meanwhile, in between the workshops, community survey with the residents, understanding that the advisory group does not represent the views of the entire community. We actually work with HRI, Heart Research Institute at Texas A&M, who was a key partner to this work and devised the survey and also administered it with the county members. But that survey was really instrumental in helping us understand what the community values are and how they use their natural resources. And then, of course, within the advisory group, there was a huge desire to align what we're finding from the community survey with what the community values are. So focusing on education, public access, and recreation as we started thinking about this Living Shoreline project. Nearly all the participants were interested. Well, I think not nearly. Everyone was interested in continued engagement. And then different ways that they wanted to engage was through providing outreach support, engaging in the monitoring and evaluation when the project started moving forward, and then the engineering piece, where a few of the advisory team members were interested in that. Next steps for this work, particularly the Refugio work, was that a roadblock that we encountered when moving the project forward was that the land is a private land, and a lot of the upcoming federal grant opportunities do not support natural infrastructure projects on private lands. So taking a step back, we really felt that there needs to be a big strategy that needs to happen for land acquisition, either through easement or other mechanisms to have more public land available, because without public land, a lot of the big pots of money that are becoming available may not be of use to counties like Refugio, where I think it's 90% of the land is privatized. But then when you look up and down the Texas coast, that's true for so many other counties, not just in Texas, but along the entire Gulf Coast, where there's a lack of public land for actual restoration projects to happen, especially for projects to happen at scale. There's also a lack of organized groups. There are lots of groups that are working across county, across state boundaries. There's National Wildlife Federation, there are other local conservation groups, but a lot of these projects are driven by funding and funding objectives. So there needs to be either a dedicated pot of funding available or some sort of mechanism to have momentum created even when the funding runs out of these projects. So a few things that we've been thinking to continue moving these conversations forward is that there needs to be this broader resilience vision through this resilience collaborative, Refugee Resilience Collaborative, that can continue building and tapping on to the momentum that has come through this project. On that unavailability of public lands piece, there needs to be a land acquisition strategy to understand what the preliminary list of parcels are, what the reasons for acquisition might be, and then understanding the timeline as well as the funding available for implementing those projects. And then finally, that community engagement and capacity building piece needs to be continued, because a lot of these projects, green infrastructure, natural infrastructure projects, require ongoing maintenance and evaluation, and that can only happen with the community buy-in. So for this specific work, what we proposed was doing demonstration sites at some of the public parks, and then training the city, county, district officials, community members, developing outreach material, flyers, case studies to work at that decision-making level for projects to happen. Taking a step back, I just want to give everyone a flavor of like the things that we're working on climate resilience, but also like how those projects shape up, and how like the data and the science we're working on is actually translating to that on the ground project implementation level. This is a bit broader than that, but sort of the climate data sets that we look into or are helpful to us are sea level rise data. NOAA has a lot of good resources on that. Storm surge data sets, both the federal ones from National Hurricane Center, but then more recently, Texas Coastal Resiliency Master Plan has started compiling some of these data sets through their own portal. Temperature and precipitation data sets are always helpful when making the case for climate change and future changes. Population, Texas Demographic Center has good population projections, but this also helps us see a lot of these climate trends in the face of how population is going to be changing, and honing in the point that a lot of these coastal ecosystems require space to function. So any future development needs to happen in light of the ecosystem migration and the space that these ecosystems need. Land cover, again, NOAA, CCAP has good land cover data, which Texas Coastal Resiliency Master Plan includes as well. Water quantity and quality from Texas Water Explorer, a tool by the Nature Conservancy, which has, I think, all the rivers and streams and how the water quantity and quality, different indicators to measure the quantity and quality of the river and streams. Critical facilities, looking at the schools and hospitals and airports to make that case for socioeconomic impacts of a lot of these risks, so sea level rise, storm surge, and how that impacts the critical facilities that are essential to the functioning. Fisheries data set, looking at the optimum temperature ranges for these marine animals and fisheries, and looking how that connecting the dots between how that would change from changes in temperature. And then also looking at ecotourism, because that is a big economic generating opportunity for a lot of these rural counties. So, and also big ecosystem service, looking at from the natural infrastructure, coastal ecosystem standpoint. So making the case on why there needs to be a need on conserving and restoring these ecosystems and making that economic point for it. In terms of climate adaptation, so these were mostly climate impacts, but then the second piece on how do we adapt to it. So the solutions one, again, there are a lot of data sets. We haven't dug deeper into a lot of these. We rely on existing case studies and literature that exists. So I really encourage you all to start thinking about it from the perspectives of how it would be useful to us. But land cover and land use data is always really helpful. Ecosystem services map on where these coastal ecosystems provide these services and where there's priority for conservation and restoration. Similarly, climate projections and models, we have some local data, but always helpful to have localized understanding of the risks and how that's going to look like based on different watersheds, different counties, on different scales. Hydrological data, biodiversity databases. So again, where there's potential for climate refugia, where there is a bigger opportunity to conserve and restore some of these ecosystems to provide that high risk reduction benefit, but also critical habitats for biodiversity and species. Social and economic data, so where these projects might be providing a big opportunity in terms of lowering social vulnerability, supporting communities that are more at risk and are often disproportionately impacted. So people of color, low income, minorities. And then the last one is the monitoring and evaluation data. I don't know how much exists in terms of monitoring and evaluation, but that really helps in showcasing the efficacy of these solutions when making the case. So getting more and more data points on how these natural infrastructure solutions, like a wetland restoration project or a oyster reef restoration project or a living shoreline, how they have performed in the face of hurricanes or changing temperature, sea level rise scenarios, really helps make the case for pushing forward these projects. Full disclaimer before we go onto the slide. I'm from a research background, but I do not have much AI or big data competencies or knowledge. But I just wanted, when I was working through this presentation, I wanted to start thinking about what might some of the research questions that y'all are working on through big data, AI tools that can support the things, or that might align with a lot of these things that we're working on. Again, the big picture goal is to inform that evidence-based decision-making for us and bring in more stakeholders so we can promote that landscape scale conservation and climate adaptation planning across the Texas coast. For our specific work in Refugio County, where we are at this roadblock on identifying more private land for the land acquisition to move forward, it would be helpful if there are tools. I don't know if there are like spatial analysis tools or data sets that can help us with those land acquisition efforts through identifying what those priority areas are for conservation and restoration. And then in terms of funding, compiling information on data sets on innovative financing mechanisms, so green bonds and easements and payments for ecosystem service schemes and how they have worked in other places to really mobilize the funders both at the state level and as well as the philanthropy and donor foundations to mobilize funding for natural infrastructure, and then also incentivize private landowners, because ultimately they'd be the one making a lot of decision on these land acquisition conversations. So this was something specific that I've been thinking in terms of that Refugio work, but then also like the broader work that we do in terms of climate adaptation and nature-based solutions in Texas. There's always that big focus for us on outreach and advocacy. So getting a sense of new like trends and sentiments and stakeholder perceptions, so we could develop more targeted comm strategy to reach different folks and engage them in the advocacy and policy around these projects. If there are ways to look at news articles or like case studies and compile them, that could show us like some good communication messaging. And then the last one I have, and this might be blue sky thinking, but even if there are like potential ways to identify how we can use some of these tools to design and implement green infrastructure projects. Some of these are more urban projects like the parks and green roofs and permeable pavements, but also like large scale ecosystem restoration and conservation along the Texas coast. That would be really strong evidence that we'd have to then start looping in the stakeholders, build that community buy-in and support, and start looking for funding for more of these projects to happen. I think this is my last slide. This is my information on the screen with my email and phone, but I wanna take a pause here, catch my breath, and see if there are any questions from your end or anything that we need to dig deeper into.
Thank you, Arson. Any questions?
Thanks for this very nice talk. Do you have information on those data where the duration of the data collections? It seems like they're from different sources.
Are you referring to the climate data sets?
Yeah, the data table.
Yeah, all of these are the data sources. And these are the climate data that I have used for my assessment. So all of these sources are here. These ones, I would need to do a little bit more digging into. The way we've talked about a lot of these things is through literature, and existing like case studies and examples. So I'm not sure if there's like actual data that exists. It might be more like region specific data sets, but I think, and I know ecosystem services, US GRP, the Global Research Program, is working on creating a data set for ecosystem services provided by natural ecosystems. but I don't have them all in one place as I have the climate impacts one.
You have a like big table or database with all the data that you have on this slide? And if you do, is it something that you could share with the students?
Definitely. I have all of these data sets in a spreadsheet, and then I have a running list of all the different tools that are coming out of state agencies. And I'd be happy to share that as well, because those tools, they have a list of indicators and variables and the sources from where they are compiling the data from. So I'm happy to share that as well.
Thank you.
Any other questions?
Is there a particular question that you think our students, that would be a good fit with our students who are studying things right at the coast? So maybe not water in general, but you've talked a lot about the importance of securing land, guiding maybe stakeholders on where they should buy coastal land, or water quality is something that you have quite a bit of data and would lead to a question that's a good fit with our group.
Yeah. So for this first bullet point on land acquisition strategies, I know there's information on the public and private lands that are available along the Texas coast. I know some of that data is trickier to access given just like land right issues. So that's something that we need to dig deeper into. But the second bullet point on like funding mechanisms, I think there is data that exists on like easements and green bonds, but I'm not sure if all of that data is in one place. That needs to be compiled, and I haven't personally compiled it yet.
That would be a challenge.
Yeah. And that's what I was hoping for, some of like through our conversations, like start refining what is more manageable for this group to come together and identify out of like these big picture gaps that we have been identifying through our work. And if there's a way I could support the data compilation of some of those things.
The use of AI to gather and analyze news article and public discourse is pretty original. Sounds like a good idea. It's big data, but in a different way than what we're working on so far in this with our group.
Yeah, I really like that. I was thinking, especially like in Texas, the amount of work that we do on education and outreach, and it's so specific to the group that you're reaching out to, the specific region that you're reaching out to. So if there's a way to design some of that strategic, targeted messaging around natural infrastructure, and I assume like this data, again, I don't have it compiled in one place, but it shouldn't be that hard to gather. Like looking through the news articles and how they've covered this topic, looking through the case studies, both in the academic literature as well as the gray literature. So many conservation organizations have been doing reports and publications. And if there are any like trends that are emerging, like clear trends that are emerging, that might really help our messaging around it, as well as like reaching out to the policy folks and at the legislature.
Good idea. As long as there's humans in the loop, that's because to avoid hallucination, that's a good idea.
Yeah. I can also see in that last bullet on design and implementation of green infrastructure projects, if there's a way to catalog existing projects along the Texas coast or along the Gulf Coast if we want to cast a wider net. Catalog those projects if there have been any like quantifiable benefits that has been showcased around those projects. And having that all in one place would be immensely helpful to us.
Any other questions? Okay, thank you, Arsum.
Nice seeing you all. Thank you so much.
Yeah. It's pretty impactful. Yeah. Yeah, using that just massive net. Yeah. Tracking up information and somehow floating. Yeah.
Entire time? Yeah. You want to advance your screen?
Yeah.
But it might.
Guys, good afternoon. Like I said earlier, I'm Katie. I am the stewardship coordinator and then also the acting manager for the Mission-Aransas Reserve. I'm gonna take kind of the first half of the presentation and then I'll let Victoria take over. So a little about, who we are. So we are, when I say reserve, it's actually the National Estuarine Research Reserve. And we are part of a national system. Our program is administered by NOAA. There are 30 other reserves within the system. We are the only one in Texas and then also west of the Mississippi within the Gulf of Mexico. There are potentially 2 new reserves coming on board in the next year or two, one on the east coast of Michigan, and then also you'll notice that Louisiana is a huge kind of gap for the Gulf of Mexico. So they're hoping to get, they're in the designation process for getting a reserve within Louisiana as well. The mission of the reserve system is to practice and promote stewardship of coast and estuaries through innovative research, education, and training using place-based system of protected areas. So in order to be or have land within a reserve system, it really needs to be protected. It needs to either be publicly owned or have some kind of conservation easement on the property. And then it's place-based. So like a lot of our research and monitoring happens within the reserve. And if not within the reserve, in the watershed surrounding the reserves. Okay. One thing I wanted to kind of start off with is the SWAMP, or the system-wide monitoring program, is kind of the bread and butter of the reserve system. And so I'll talk about the 4 different programs within the reserve, but the SWAMP is incorporated in most of those programs, but it is a system-wide monitoring protocol. So all the data that Victoria and I are going to talk about today, at some level, all 30 reserves are also collecting the same data using very similar, if not the same protocols. We have protocols that are established by NOAA, vetted through the system, and then we all agree on certain ways we do things. So Victoria does the water quality. She is doing the same protocol. She is checking the YSI QCing the data the same way that all 30 of the reserves are doing it. When I'm out doing marsh monitoring, the folks in North Carolina and California are taking the same type of measurements, and we have the same type of transects set up. So you can compare the data, it's apples to apples. It's not really apples to oranges. And they did that on purpose so that you could actually do a system national-wide analysis of a lot of our data. So here is our reserve. We are the third largest currently in the system. We're just over 86,000 acres. We encompass Copano and Aransas Bay, and then also Mesquite Bay up at the north. And then we also have a conservation easement up at Fennessy Ranch, which is that larger, can you see the parcel up here, up the Mission River. We encompass also the Aransas Wildlife Refuge is within our boundary, Goose Island State Park, and then properties owned by the Coastal Bend Bays and Estuaries program as well. Here are some of our, quickly, one thing I did want to mention. So each reserve has NOAA as our kind of, we call them our federal partner or parent. And then we have a local partner. Our local or state partner is the University of Texas at Austin, the Marine Science Institute in Port Aransas. So we are academic, kind of related to an academic university, where other reserves have more of a resource management partner. So instead of being partnered with UTMSI, we would be partnered with like Texas Parks and Wildlife. Having the various partners makes the reserve system very diverse. So we are very focused on monitoring, research, or science-based reserve due to the fact that we're related to a university. Other reserves actually have to spend their funds and a lot of their resources, maybe owning or managing the lands they own. So we, as you can see on our map, we don't really own much of our reserve. GLO owns the bays. You know, U.S. Fish and Wildlife owns the Aransas Wildlife Refuge. We own this little parcel down here, our campus, and then we own the conservation easement up at the ranch. Besides that, we're able to spend a lot of our resources on research and monitoring. Here are just a few, or here are most of our facilities. So our headquarters are on UTMSI campus, which is that larger photo. The building with the white roof is the Estuarine Research Center. So that's the ERC, that's where we're headquartered. We share that building with UTMSI labs as well. The Amos Rehabilitation Keep, or the ARC, is located right here. And then we also have some educational and outreach tour or trails around MSI. That welcome sign is the entrance to the Fennessy Ranch. And then we also have facilities in Rockport, the Bay Education Center. We would not do 99% of our work without our partners. And our partners range from NOAA and U.S. Fish and Wildlife on the federal level, all the way down to local NGOs, local government, City of Rockport, City of Port Aransas, other research facilities, universities as well, and NGOs, as I mentioned. So I'm gonna dive into some of our priorities. So it's kind of set the tone. So I believe there's 5 listed. These are the reserve priorities. We basically do a gut check every year or two. These are what the programs identify. These are what we submit to NOAA. These are what we submit to our partners, to you guys, and present on as topics that we feel the reserve are important to the reserve to focus research, monitoring, protection, and restoration on. So habitat restoration, we need to protect key habitats. We need to be able to identify what those key habitats are, identify what ones need to be restored or protected, and then also how to do it. We need to understand how those habitats are related to declining species. For example, one of the biggest examples we have right now is the whole mangrove migration. You have salt marshes transitioning to mangroves. What does that mean for the whooping cranes? How are other, larval fish species that depend on salt marsh habitat, how are they going to be able to utilize, if they can utilize the mangroves, and what that change is going to look like? Shoreline stabilization, so that green infrastructure practices, living shorelines, stuff like that. And then understand effects of hydrological alterations to estuarine hydrodynamics. Especially when so you may have noticed on the map, we are right along the ship channel, the Corpus Christi ship channel. So understanding how the deepening of that ship channel is gonna change the hydrodynamics, impacting Harbor Island, the mangroves, erosion rates, stuff like that. Water quality, so one of our things that we've focused on really since the beginning, we have been established since 2006, is freshwater inflows. Texas is very water limited, so understanding how the estuaries change with the change in freshwater inflows. Understanding how the estuaries and the species depend on those, not just the lack of flows, but then all of a sudden you have the flood events. What does that mean for the pulse of nutrients, sediment into the habitats and into the bays? And then improving water quality through wastewater or stormwater, again, kind of tying that back to also green infrastructure practices. Assessing marine debris impacts. We've done a few different long-term marine debris projects. Currently, we don't really have any, well, we have Nurdle Patrol going on. So we partner with Jace Tunnel here at the Heart to continue to promote Nurdle Patrol. Larger marine debris projects, we did a 2-year monitoring project from 2015 to 2017. We are hiring a marine debris specialist to start back up some of these long-term, not long-term, but marine debris accumulation trends and understanding the impacts. Understanding HAB dynamics or harmful algal bloom dynamics is also our previous research coordinator was Dr. Ed Buskey. That was really one of his kind of his focuses. And so we've incorporated it into SWAMP. We've done it from the beginning. We'll obviously just continue to do HAB monitoring, taking the samples, understanding the dynamics of these harmful algal blooms. Effects of climate change is a huge one. So engaging local communities in coastal resiliency planning, identifying climate change impacts. So taking the data that we collect, we are mandated by NOAA to collect. We have guaranteed funding to collect year after year, and then understanding how climate change is how we're able to actually read climate change through looking at our data, but then also model how it's going to impact the habitats and the wildlife. And then doing biodiversity monitoring and baseline data. Again, these are very broad. We have very specific, yet broad research interests. I do everything from marsh, mangrove, marine debris, soundscape ecology, but we can't do it without partners. And so we keep our priorities pretty broad so that we can partner with people that come up with ideas, interests, and say, yes, that fits our priorities, let's move forward. And then ecosystem services and monitoring applications describe how to communicate ecosystem services. So as the previous presentation, a lot of times we present on ecosystem services, but then we don't know how people are responding to when we say ecosystem services. So kind of being able to communicate, but communicate in a way that we know the communities and our partners are listening. And then again, the SWAMP data, you'll see where what we collect for SWAMP, where it's at, how much data we actually have. The NERR system, the last probably 5 years, we've really put a priority at starting to analyze the data. Our in the past, we used to say, promote how we were collecting all this data, and we're still collecting it. We never did anything with it. And so the reserve system kind of started to realize, we have all this data, we need to start analyzing it. So they are producing our packages to look at the surface elevation data, the marsh data, the water quality data. So you guys can just put in the SWAMP data into these R packages and see what comes out. So each reserve has four main sectors or programs. I'm stewardship coordinator. Victoria is the research coordinator. Our two programs work very closely. You'll see here in a second. And then we have education, which is Adriana Reza, and then CTP, or the Coastal Training Program. So every reserve in the system has, or pretty much every reserve has these four programs. And then each program kind of has their own direction or needs, but then we also do a lot of collaboration. There's a lot of bleeding between programs. So Coastal, or CTP, I describe this program as basically she's the one that bridges the science to the policy or the resource managers, the audience. So Joan, or the CTP coordinator, will go out to the community, go out to our partners, go out to grad students, the undergrads when they're at UTMSI, and ask what they need for training, whether it's GIS training, whether it's coastal resiliency, how to write a grant, and then she'll bring in experts and meet those our partner needs. And then she also does a lot of workshops, facilitations, stuff like that. Education, we do basically K through grade. So Adriana meets with thousands of kids, school groups, families every year. Not only at our facilities, here is our Patent Center at UTMSI. At the Bay Education Center, we do have a science on a sphere. If you have not seen it, I would highly recommend. It's like the coolest giant white ball ever. And so we do host things on site, but then we do have a vessel program, and then she'll go off site into the schools, into partner properties, and do programming as well. Stewardship, I'm going to kind of expand on some of these, but like I said, stewardship kind of ranges. I focus mostly on the careful management of natural resources, which is very broad. So I do everything from parts of the swamp program to marine debris. I do a lot of invasive species removal, mapping, stuff like that. I'm tasked with a lot of the restoration projects and monitoring those, and then doing outreach education. And we also, 4 years ago, we took over the daily operations management of Tennessee Ranch. So I'm also the ranch manager for the ranch, and do that on a daily basis. So I was going to quickly kind of talk about the protocols. So we monitor mostly, at least stewardship monitors mostly 2 habitats. We do marsh and mangrove. This right here is kind of showing our mangrove setup. And so we have this at 2 sites, Harbor Island. If you know where the lighthouse is, it's literally right across the channel from the lighthouse, and then also on Mud Island. And Victoria will show a map of where some of these sites are. But with the mangrove monitoring, we have the lighthouse channel, and then we have 5 transects. And then within those 5 transects, we have 4 10x10s for each transect. And so this would be an example of a 10x10. And then within each 10x10, we have 5 trees tagged that we go back to year after year after year and do a number of different measurements on. And then we also have 3 1x1 plots established within each 10x10. And within those 10x10s, or within the 1x1, we also count and measure every tree within that plot. And so it's a lot of data. We've been collecting mangroves since I believe 2012. And one thing I want to say about swamp is we're doing this for long term, and we can identify climate change impacts. But the really cool thing is that we have these protocols established that we can also see short-term impacts. So like the mangroves completely froze and died off in 2021. So I had data, I have 10 years of data before the freeze, and now I'm going out there every year and collecting the same data and understanding the regrowth and the recovery of these habitats. Same with like Hurricane Harvey. It hit right in the middle of field season, so Like I went to the Aransas Wildlife Refuge Monday, it hit Friday. I was back out there the following week and was able to get like true pre and post data of the storm. Here's just example of the freeze data. So again, you can see we have almost 10 years, sorry, it was 2013, and you can just see, and you can, I mean, we're able to see Hurricane Harvey had minimal impact on this habitat. The freeze truly had the major impact, at least here at Harbor Island. This is just kind of, this was a real quick analysis of the data. We also do the marsh transects. These are 5 transects, 20 meters long, and then we have smaller 1/4 meter plots that we take specific measurements in at every plot. And we have these established. We had them established at the Aransas Wildlife Refuge. We stopped monitoring there because the vegetation loss was a waste of time to set the transects up anymore. It took more time to go out there, set up the transects than it did to take the measurements anymore because the marsh had just disappeared and has become more of a mud flat at that particular site. We did establish a transect or a site on Mud Island after Harvey. It was an area where, you know, I think probably a foot or 2 of sediment had dumped on top of a marsh. So when we set it up, it was a sand flat, and now we're watching the Spartina and marsh kind of march back into that plot. Here's that site. So just in the 4 years, this is at the Aransas Wildlife Refuge that we're no longer collecting data. You can see there was, and that was 2018, and then even now it's, you know, we've lost even more data, vegetation with another 5 years. And so that was something like, because of the protocol, because of the funding that we received, we're able to kind of see these changes. Then the other thing that stewardship program does is we focus on our elevation change. So we have these instruments called surface elevation tables. We have 6 different sites around the reserve with 3 different sets at each site. And so a set or a surface elevation table is basically a stainless steel rod that is jackhammered into the ground. They're in segments, about 1 meter each segment. And you jackhammer it in, you attach another rod, jackhammer it, till basically like 2 minutes of resistance with the jackhammer. So then you know that that rod has hit bedrock and it is not going anywhere. And so all the sediment on top could be, you know, sand and dirt and silt. And so that's gonna move, but that rod and the attachment on top of it is not moving. And so twice a year, we bring this instrument and we attach it. And then I lower the rods to the very tip of the sediment and we measure from the top of this instrument up. And you're getting very precise millimeter elevation change for that location. And then at the same time, we put feldspar clay down. And so then we're able to actually understand if there's sediment coming into the system or if it's eroding. If we don't see the clay there, after like 2 years, it means the sediment's eroded, but like, we know exactly what day we laid that feldspar clay and we'll core year after year, and so we can see how much sediment is actually coming into the system. And here's just an example of one of the analysis that the R package does. So it'll, you know, take the data or tell you whether or not you're accreting and your rod is going higher, or if you're eroding and your pin's going down. But the most important thing this program also does is it tells you, like, maybe you do have sediment coming into your site, but is it enough sediment to keep up with sea level rise? So you might have like a positive sediment and a positive change with your set, but it might not be enough to, you know, keep up with the sea level rise. So your marsh is still technically drowning. So here's just a quick kind of analysis or summary. Again, marsh, we have 2, I put 3 because of Anwar. At each plot, we do percent cover, species identification, density of that species, and then canopy height for the tallest individual. Mangroves in the 10x10s, we do percent cover, species. The tag trees, there's, I think, 8 measurements for the tree, including height, diameter, canopy axis, wide, narrow, stuff like that. The 1x1s, we do percent cover, species, density, canopy height, and then diameter for every individual within that plot. And then the sets, again, we do rod height, marker horizon. We collect water depth at most of these just to have it. And then one thing we do with this sets every 5 years to understand if the rod or if like the bedrock is moving is we'll do long-term RTK occupation about every 5 years to understand using satellite data if the rod is actually moving or not. Restoration, we have a number of restoration projects. We partner with CBB EP for most of them. This photo is Egery Flats. So the Basin Estuaries program went in and replaced 2 large culverts to try to increase hydrology in that system. We've been collecting data for that project since 2016. It's pore water data and then also vegetation transects. And we just got a 3-year extension to do additional. The project was completed in 2017, but we're going to continue to do post-project monitoring. This project right here is just Brazilian pepper tree removal, understanding how the native vegetation came back. It's a very successful project, but as you can see, it actually was surrounded by really healthy, not the track, but healthy dune systems. And so that project really took off on its own, where some of our other Brazilian pepper tree or invasive removal efforts, you really have to go in, continuously retreat, put in plugs, try to help rebuild the seed base. This is Dead Man's Island. This is a project that should be kicking off soon. It's a Rookery Island rebuild. That was some of the BIL, kind of that big money from the government restoration. We also have some planning and engineering for living shoreline work along the refuge in St. Charles Bay. And then we did just find out we received 1.2 million to do a living shoreline and oyster reef restoration, partnering with Jenny Pollock's lab and CBBP to do additional oyster work in Mesquite Bay. This is just a slide to talk about Fennessy. Again, we do the daily management of the ranch, but we're also doing research. I've established biannual vegetation monitoring there. It is part of the UT field station network, so we're starting to get more and more UT Austin research folks coming in and establishing plots. For example, one group came down and established and tagged a bunch of the prickly pear cactus looking for the invasive moth and how it's kind of marching over or through Texas. So we have some uninvaded cactus on the ranch so far. So they're able to use that as a monitoring station. We had a herps class come down from UT Austin and they're helping us build the herps database for the ranch. We have the bird database and the vegetation, but they are really focused on getting the snakes and other things that I don't want to touch identified for the ranch. And then we're starting to put birding back on the ranch. So we'll monitor how that goes as well. Again, it's just a very diverse ranch. It's about 3,300 acres. I'm gonna let.
Oh, damn, I'm exhausted, Katie. Is there anything you don't do? Maybe this part right here, research, although she comes out in the field with us. Okay, so Katie gave us a lovely introduction about our bread and butter, right, swamp. This is the water portion of this program. And here are and Dr. Who's quite familiar with these, I believe. But we have 5 stations in the Mission-Aransas. Our ship channel 1, which finally was rebuilt after Hurricane Harvey, the ship that took it out. And so we just got that one in January. Aransas Bay, Copano East, Copano West, and Mesquite Bay. And so essentially, if you ever head out to these areas, we'll have these platforms, as we can see right over here. And this is where we deploy our sondes and our meteorological station, which is located in Copano East. So what do we collect at these platforms? Well, we have a swamp technician that goes out every 2 weeks when it starts to get warmer because of biofouling, and then monthly. And so we swap out the sondes, and we have these exos over here. And so again, as Katie had mentioned, all of the NERRs across the US and across collect these exact parameters. We collect a couple more, but for the most part, you're gonna find all of these throughout all 30 reserves. So you got your water temp, connectivity, salinity, DO, the whole suite over here. And then we also collect nutrients. So those are water samples that are collected right at where those sondes are deployed about half a meter off the bottom. And we also process those for chlorophyll. And then at 2 stations, which are Copano East, that's our primary station, and now the ship channel, which we're getting back up, that's our secondary station. We collect this assortment of parameters. So air temperature, relative humidity, barometric pressure, wind speed, you name it, you got it, it's all right here. In addition to our water quality and nutrient monitoring in the reserve, we also work with Dr. Ken Dutton on the seagrass monitoring in this area. And so very much about this importance of standardized collection and monitoring. This program follows the same thing proposed by Hillary Nichols, in which you have a collection of samples. So over here in the Mission-Aransas NERR, we have 57 stations that we visit annually. And that's done during peak biomass, so during the summer. And you visit 1 point within each of the stations. And you do that as fast as you can, ideally 15 minutes a site, collecting various seagrass parameters such as percent cover, canopy height. We even do some PAR values as well as water quality. And then normally within one of these, say these bay systems, you'll have a fitness site. And we had 3 located in total in Mud, and then Hog Island and Trailer Island. And at these, you might collect more intensive parameters, either your tier 3 ones. So this is anything, say, chute density, coupled with percent cover, coupled with biomass above and below ground. Maybe you're collecting for isotopes of carbon and nitrogen, and maybe collecting pore water as well. And so ultimately, with these data, you can get a map of what it looks like from year to year. And what's really important about this is you're able to really take advantage. So say, for example, Hurricane Harvey. A lot of times you don't have pre-data. You might go out there and you'll collect post-data, but you're like, I need the like, how can I quantify this? And so that's what's great about using some of these long-term monitoring programs, is because a lot of the times you can really take advantage of that opportunity to evaluate and assess pre and post disturbance. And so also habitat monitoring is another component of the research sector, and Texas Parks and Wildlife has been working really hard on this. It's a very long, arduous process. And so they're making headway, and they just finished the reserve area all the way up to, is it Mesquite Bay? It kind of maybe like that's kind of the cusp probably of it, and they're going to keep working along the north. But what we're responsible for is kind of crosswalking this over with NOAA, making sure the categories line up, and then doing the upland part ourselves. So Katie mentioned we have this map here. This is just a summary of a lot of the permanent stations that we currently have within the reserve. We have 18, which is a lot if you have ever done surface elevation tables. Has anyone had the pleasure? No? Oh, you're missing out. So we have 18 of those, which are located across three reps for 6 sites in salt marsh, tidal floods, and mangrove. We also have 7 vegetation transects, so 3 of those are SAB, so seagrass is what we'll call them. And those were performed and monitored several years ago. They've kind of been neglected, but I am hoping to bring those back coming up this summer. But we also have vegetation transects, as Katie had discussed, about mangroves and marsh sites. And then we have the 5 water quality sites within the NERR, which are these black dots over here. And then the 2 meteorological stations at the ship channel, Coconut East, bless you. And then these are the vegetation sites that Katie was discussing earlier, and these red diamonds are the surface elevation tables. And then we also have the capacity to monitor, I think I had heard some people about groundwater in here. So we also have a bunch of CSARs, SARADs, and equipment in place that we can do for water salinity. Okay, so how do we get these data? There's a ton of data. This is always a question, I think, from a lot of people. Where do I go about getting it? And if you are interested in surface elevation table, vegetation, transect data, so those marsh and those mangroves, some soundscape data or egg flats imagery, Katie Swanson is your go-to. She houses a lot of those data. Ultimately, the vegetation will be posted online, but it's a process, as I'm sure y'all are quite familiar with. But if you're interested in the water quality data, you can access that online by visiting the CDMO website, which is listed here. And so that is, again, the water quality, meteorological data, and nutrient data. And not just for our reserve at Mission-Aransas, but if you're interested in going bigger, larger, you can go here to find the other reserves. So what does this look like? So this is essentially, you just kind of redid this website. If you go here, at the CDMO site, this is going to be what your first, what's in your face. And you can click on view and download data. And then you'll choose your reserve. So this is just all the little images of where all the reserves are located. We are interested in this one. So then once you select the reserve that you're interested in, you can pick, what station. So we said we had 5 of the water quality and then 2 of the meteorological. And this is the station name, and then when it was active, so when you actually have data starting, at the start point, and then what is being collected. So if it's water quality, or is it meteorological, or maybe it's nutrient data that you're interested in. And so this is pretty much all of the data that you can gather from this website for the Mission-Aransas. So once you figure out what you want, maybe it's water temperature, maybe it's salinity, you'll go ahead and just select your parameter, and then whatever year time frame that you're specifically interested in. And so just as an example, if you want a really quick and dirty graph, it'll spit it out for you. So it's really great for this. And here we're looking at the Aransas Bay water quality for salinity and temperature. Now, I would like to point out that all of our graphs are going to have big data gap. And that's because we were in between swamp technicians at the time. And so during our search, we had to retrieve the sondes from the water. They were just going to get fouled, and you have to, as part of being a very standardized process, we have a very strict calibration and post-calibration process. So all of them are going to be missing this time period in between the old swamp technician and then the new swamp technician. Now, what was really interesting are if you're interested in real-time data. And so Katie and I were discussing this, and I was like, oh, wow, gotta hurry and get these up, because a lot of people, specifically like fishermen, are really interested in looking at these data. And so if they're curious to go into Aransas Bay, what are the conditions like? They'll go ahead, pull it up, Bam, there you go. So we're getting there. Well, we're not there 100%, but I promise my goal is to get this up hopefully for all the stations by the end of the year, ideally sooner. But if you were interested in looking at this real time, you would click on this website right here. And then it would pull up all the reserves. But let's say we're interested in the Skeet Bay water quality at the moment. And then here we're looking at temperature. So it'll list all the parameters and it'll graph it out for you for the last 48 hours. So it's pretty handy. And I think with that, that concludes our talk.
Any questions?
Yeah, is the seagrass data on that website or is it with the other vegetation for salt marshes and group?
Yeah, well,
Is it?
you can
Texas
access it on www.texasseagrass.org. And so that will be for all, not just necessarily the National Estuarine Research Reserve hexagons, stations, but you'll also go all the way down from pretty much Galveston Bay, all the way down to Lower Laguna Madre, so South Bay. Now they all start in different years, but the program started in 2011. So you'll have your core data sets for Lower Laguna Madre, Upper Laguna Madre, the coastal bend area, which includes the National Estuarine Research Reserve, and then Corpus Christi Bay.
Yes, Patrick?
Yes, could you show me that link again that had the real-time data? Thank you.
Before, yes, that one. Yes.
Are there any questions that you have, not just at your reserve, but across all the other reserves in the United States? Is there maybe according to climate change or anthropogenic activity or anything like that?
So like every year we get together, at least with the Gulf reserves, and kind of set priorities also. And one thing that is constantly kind of coming up as a topic is species migration. So the Gulf is really within that like hot zone of where we're seeing not just like mangroves, but other species. How birds are migrating differently. We're seeing a number of southern birds come into Texas now. And so that's been really identified as one of our, at least the Gulf region topics. Trying to think. Joking. We are about to finish up a NERR-wide analysis of marsh data and connecting it to the swamp data. So that'll probably produce a lot of additional questions. And so the researchers are really trying to tie like loss of habitat and then looking at what water quality specific parameters might be able to explain that loss of habitat. And so I feel like that analysis is going to be a jumping off point for a lot of this other kind of national level potential questions that people have.
Actually, to amend what Katie said, there is the study 2018 Estuarine the coast. There is a Yukon scientists, a pair of Yukon scientists, they compile all the dissolved oxygen pH data across the entire NERR network and looking at the trends. So that's climate related.
And then those R packages that Katie had mentioned earlier are on that view download data main. If you click on it, it'll list, it's a different version of kind of seeing real-time data, download export data. And then there'll be the packages themselves. So there'll be like swamp rats, I think, and all the widgets and stuff that you can use as well on there. And then what's nice too is you can download the data and export it as CSV and then do your own manipulations and organization and tidying and all that kind of stuff with it. So once you put in your timeframes of what you're interested in.
How often do you do the marsh transect and the elevation table? Once a year? Is it?
Elevation, the sets are twice a year.
Okay.
We were doing them once a year until Harvey hit and we saw how much sediment moved after that event. And so we started doing them twice a year in the fall and spring. And the marsh and mangrove is once a year peak biomass, so usually August, September.
And that sounds pretty exciting that you're combining those data sets. How much work is being done, and are there open questions where they could relate the marsh and elevation table with bigger data sets, or is it, what's open? Because they probably shouldn't redo something that's already going on.
No, I know, and I'm trying to think, I have a question with or a meeting with the Namaste, that's the project name, folks. And I can send you guys the link and description of what that project is. They're at the very tail end. And see if there's other questions or what I don't know. They are connecting it to set data. It's like, I'm not sure if they're incorporating the set, but they are, because I've filled out that data. So yeah, I'll see what exactly they're doing. Yeah, like it's a very intense, I think they took on a lot more than what they thought. Doing the national analysis. You know, we had to identify specifically what species we thought were the key species for every reserve. Whether it was succulents, grasses, mangroves, and then they use those top species as the indicator species.
Victoria, you mentioned on this slide, the big data gap. Is there metadata with the swamp data that explains any of these large gaps or has that information?
Yes, so that is one, another benefit of these standardized program is that every time we submit quarterly and annual data, a metadata file goes with this. And so a lot of these data will either, when it goes to the QA/QC process, it'll be coded initially, we'll go through it. We'll say, okay, yes, this is very suspect. We'll say, no, this is bad, disregard. And so when we have metadata comments, it'll say C comments, and then that's where we'll list specifically, what might be suspect about these data or explain gaps and stuff, so.
Salinity is hard.
Oh, yeah.
Not for the faint of heart to do.
Philip, have you tried to model salinity?
Yeah,
And
different
you
ways.
didn't find any
So
good
localized.
correlations with precipitation, stream flow?
I think HRI does that also. We did some modeling with the hydrodynamic model. We're doing it with AI. It's
But
different.
not using terrestrial, like stream flow discharge.
Yeah, also.
Yeah, and precipitation.
Yeah, but
Not predictable.
we've never been funded for it, so it wasn't super intensive, but
Yeah.
just, and then you have a lot of gaps. You have to establish the quality also. Is it every 2 weeks for that you're going?
So we do in the summer in particular, I think it's starting March through October. We go every 2 weeks just for biofouling because,
Yeah.
it starts to creep up right now. Those oysters, is that what? No, barnacles. And so, yes, during the warmer months, we go every 2 weeks to clean, we swap out our sonds.
Yes, there's the question of when is it starting to foul? When should you cut it off? Is real.
I have a question. You are mentioning the ecosystem is shifting from salt marsh to mangrove. Do you know why is that?
Basically the lack of freeze, which is funny. But so, yeah, I mean, it was the transition. We just didn't have a really solid freeze since in 2021. But then before that, I think it was like 1988
Yeah.
or something.
88,
and
89
so
winter.
historically, that's what kept the mangroves kind of in check and, and smaller populations. But the 2021 freeze just really took them out. And the recovery is very patchy. So the areas that were like 100% mangrove are really kind of recovering in a much slower, patchier kind of way than marshes that actually had salt marsh habitat that kind of survived that freeze, but and kept the sediment somehow healthier. I am not a biochemist. So it kept the sediment healthier, and I feel like that kept or allowed the mangroves to recover better in those areas than areas that were like 100% mangrove. But yeah.
Very interesting. Anyone's looking at like the carbon contents of the.
Right before the freeze, we did put a carbon flux tower. There was a UT Austin faculty member. She put in a flux tower right next to our sites. And then I think I'm not sure if the faculty here, oh my gosh, I'm having a brain freeze. Donna and Ed Profit. I don't know if they're doing much carbon work or not. But I do, Ashley Matheny is the UT Austin faculty member. I know she continues to come down and take biosamples. And then there's also mangrove.
That may, because there could be like a shift. The blue carbon, I think people are I'm not blue carbon, but they are very interested in the carbon sequestration by those different systems. But if there is like a big shift, it's gonna be or in terms of carbon.
That's pretty interesting because we didn't have big freezes since the 89.
Yeah.
And then historically from 1880, there's one every 10 years. So it was a big gap. And then those past 4 years after Uri, we've had 3 pretty cold winters, or at least one big event. So we have warming on average, but those freezes.
They're like, and they impact I feel like, so I tagged trees in the fall of 2022, because there were small saplings. And then we had that freeze, and it wasn't a very hard freeze. I mean, it froze, but nothing, maybe a few mangroves in the past would have survived or died, and mostly would have survived, but every tree that I tagged died in that small freeze, because I feel like there wasn't a buffer, they weren't buffered by all the other mangroves. And so the saplings are really having a hard time even now getting through the smaller freezes. So I'll just keep on tagging and going down the alphabet.
It's super interesting because is it a special event driven or is it average driven, and what can we?
Yeah, and like you see like, oh, the freeze of 2022 wasn't that bad, but the impacts were just as devastating because they were still kind of tore up.
Yeah, it's super interesting.
Is there any information on the duration of the freeze? Like how long it has to last for it to be?
And again, it might just be how soon after it came from the most recent freeze. Dr. Osland, Mike Osland does a lot of freeze, mangrove freeze work. He's USGS out of Lafayette. And he does a lot of freeze mangrove, but then also the migration work as well.
He's giving a seminar soon, right? Is it through you? Something came out on the listserv recently that he's giving a seminar. Maybe it was the Clean Coast, Texas. I'll find it. If students are interested, I can send it.
He's really good.
Audrey, yeah, because it'll be, I flagged it because it'll be a really interesting seminar. I just can't remember who sent it out now. Was it you guys?
No.
Oh, yeah, I'll send it too. I'll send it.
I was like, I know, I was like, I want this.
Yeah, I can't remember where it came from. Yeah.
That's not part of the swamp suite, but is anybody collecting bacteria data in the NERR?
Not that I know of. There's no, and one other thing that to add on, we do have a lot of additional researchers or scientists from other labs or partner labs that go out on the swamp runs. So grad student, there's grad student, grad students it's kind of like we offer a free boat ride, but you may need to take a Secchi disc reading for us or something. But it's, so there's not just the swamp data is being collected on our runs, but additional information. And it's, is there bacteria?
I don't think, yeah, I don't think we've had anyone with the experience.
Yeah, well, if the students want to learn, extract the NERR data, I have the MATLAB code written to parse the entire thing. So save a step.
Any other questions?
From a non-biology, from a number crunching guy, is the mangrove really the species that we should follow if we want just to follow one? I see them a lot around when I go on boats and put sensors, etc. But is it too narrow?
It's hard.
It's hard.
Because it's not my favorite species.
Oh, so what is your favorite species?
It would be like Batis or Salicore. I like
Okay.
succulents.
Okay.
Mangrove, I just have really, it was hard to monitor. When it was like healthy in 2020, it was, 3-4 full days of field work. Now it's a little easier. So it's my disdain for it is getting less and less because I can get out there and be like 80% dead, 20% alive, like only 5 trees or whatever. But yeah, I like my Batis and Salicornia.
Okay.
But did you say that this is the result of freezes? Did you notice maybe more higher tides for longer periods of time and more saltwater intrusion?
I would say that, yes, the water levels, especially for the few years after Harvey, seemed much higher than normal. And I think that was the biggest factor for that Aransas wildlife, that marsh site was, we just saw higher, every time we were out there, it was higher water levels and then less and less vegetation. When we were out there last fall, some of it, like the mudflats were exposed, and they were cracked, but it's very stark contrast of where the mudflats are, and then there's the stickless kind of along the outer rim of the sites. But I think that water level may impact more the marsh than the mangroves.
And the water levels were high around a Harvey, and for 2 or 3 years, we had really substantially at least half a foot to 2/3, half a foot above mean sea level, and they're back to mean sea level. The interannual variability of our sea levels here is actually pretty large. The range is as large as the seasonal range or the tidal range.
Yeah, it's crazy. And that's one of the funnier things when we all get together, like system wide, we talk about our tidal range. And I'm like, like half a foot is like, and people are just like, cause like on the northwest, it's like, 6 feet. And I'm like, huh?
Yeah, but our elevations, right? I mean.
Oh, yeah,
It means something.
It's
More than it used to
understandable,
be.
but it's just funny because they're like, their transects have to be, I think they sometimes do like 800-meter long transects or something. And I'm like, yeah, 20. Nothing's changing. There's no elevation change here. But it's just.
Do you think that it's the average water levels average monthly water level, or it's the high water level events that matters?
I would say probably monthly, because an
Monthly.
event, it goes
In and out,
Yeah.
and then the vegetation recovers, et
Yeah,
cetera.
I think it's the long term, the
Okay.
chronic stress.
And how long does it take? Like if we have like a 3-year of above average water level, that's probably enough to make a big change. And then if it's followed by 3 years of below water level average.
Yeah, it'll be interesting to see if that Aransas, we have sets at that Aransas site, so I still go back there every year, twice a year.
All right.
So if we start seeing the marsh kind of migrating back into the mud flats, then the PVC poles, I kept them in because I wanted to make sure I still knew where the transects were. So I've I've pressed pause on that site. We'll see if they're, like, if I start seeing like some recovery is something, we can go back and start monitoring.
Any more questions? Okay, thank you, Katie and Victoria.